This is the second lecture of week 2. So in the previous lecture, we talked about two disadvantages of the linear probability model. One disadvantage is that it models a probability of dependent variable equaling 1 as being linear. So for instance, if you're trying to model what is the change in predicted probability of being denied if the PI ratio increases from 0.3 to 0.4, and if you're trying to measure what is the change in predicted probability of being denied if PI ratio increases from 0.6 to 0.7, you see that change in predicted probability of being denied is constant regardless of whether the PI ratio increases from 0.3 to 0.4 or 0.6 to 0.7. But sometimes we may not want to model it this way. So in our case of modeling denial rate based on PI ratio, the denial rate probably increases little when your PI ratio is already really high compared to when the PI ratio is pretty low. Also, the second disadvantage of linear probability model is that the probability can be less than 0 or greater than 1. So in this case, if you're to estimate the predicted probability of being denied when PI ratio is equal to 0.7 would be almost 1.2, which is greater than 100%. And since the probability ranges between 0 to 1 or 0 to 100%, having a predicted probability that's greater than 1 or 100% doesn't really make sense. So these are some of the disadvantages of linear probability model, which arises from fitting a straight line into the observations. So in this lecture, we're going to talk about another option, which is a nonlinear model called Probit. So the Probit model is nonlinear model, and you can see that from the graph that the line actually looks more like a letter S than a straight line. The Probit model actually improves upon the two disadvantages of the linear probability model. So first of all, the Probit model actually models the predicted probability of being denied in this case as nonlinear. So for instance, if you were to measure the change in predicted probability of being denied when PI ratio increases from 0.3 to 0.4 is much higher than when if you're to measure the change in predicted probability of being denied if PI ratio increases from 0.6 to 0.7. As you can see from the graph, the change in predicted probability of being denied is much smaller when PI ratio increases from 0.6 to 0.7. It also models the predicted denial rate as something between 0 to 1. And you can see that from how the graph doesn't go above 1 or below 0. So in other words, no matter what the PI ratio is, the predicted probability of being denied never goes below 0 or above 1, which is another advantage of Probit model over linear probability model. So the Probit regression models the probability that dependent variable y is equal to 1 using the cumulative standard normal distribution function, or phi z in this case, evaluated at z is equal to beta 0 plus beta 1x. So the model can be written this way, and we call this whatever is inside the function is called z value or z index. So let's suppose that beta 0 is equal to -2, beta 1 is equal to 3, and x is equal to 0.4. So in this case, if we plug this into the function, then we get phi is equal, the function of phi of -0.8. So basically, this is the area under the standard normal density to the left of negative 0.8. So in order to calculate the area under the curve to the left of the value negative 0.8, we can use the table for the cumulative standard normal distribution function. And just looking at the table for the value of z, we can see that the area under the curve to the left of negative 0.8 is 0.2119. In other words, the probability in this case would be 21%. In practice, we won't use the actual table, we'll use data to calculate this probability. So to summarize, we use the Probit regression because it allows us to compensate for some of the disadvantages of linear probability model. So we said that Probit model allows us to model x and y relationship in a nonlinear way, and it also constrains the probability of y equal to 1 as between 0 to 1 for all x's. Also, Probit model is easy to estimate. Most of the regression software or statistical software allows us to easily estimate Probit function. And the interpretations are also pretty straightforward too. So whatever is inside the standard normal distribution is considered z-value. And given x, we can actually have a prediction for this z-value. So in Stata, we use this command called Probit. And because we want to estimate heteroscedasticity robust standard error, we use this option of comma robust or comma r to estimate a Probit regression function. It generates the data table that is pretty straightforward. So these coefficients gives you whatever is inside of the standard normal distribution function. So in this case, the coefficient for PI ratio is 2.97 and the constant or intercept is negative 2.19, and the standard error is also generated by the command. So one of the disadvantages of using a Probit function is that the coefficients that you get from Stata table is not easily interpretable. So in our case, we got coefficients of negative 2.19 and 2.97 as coefficient for PI ratio, but from the coefficient, it's hard to tell what is the relationship between PI ratio and the probability of being denied because it's not a linear model. One thing that we do know is that because the coefficient for PI ratio is positive, this means that when PI ratio increases, the whole z-value would also increase. And if the z-value increases, that means that the area under the curve of the normal distribution function would also increase too. So for instance, if z actually increases to a bigger value, say z prime, then the area under the curve to the left of this value also increases. So in other words, since the coefficient for PI ratio is positive, we can tell that the PI ratio has a positive relationship. When PI ratio has a positive relationship with the probability of being denied, in other words, when PI ratio increases, then the probability of being denied also will increase. Now let's look at what happens to the change in being denied, probability of being denied, if the PI ratio increases from 0.3 to 0.4. We can calculate this by plugging in 0.3 and 0.4 into the Probit regression function, and we get 0.097 for when you plug in 0.3 for PI ratio and then 0.159. Which means that when the PI ratio increases from 0.3 to 0.4, the probability of being denied increases by 6.2 percentage points, which is the difference between the two probabilities. Also, if you were to calculate what is the effect of change in PI ratio from 0.4 to 0.5, you get that the probability of being denied actually increases by 8 percentage points. So as you can see, because Probit is a nonlinear function, even though x changes by 0.1, how much y changes actually differs depending on what the starting point is. So in this case, if x increases from 0.4 to 0.5, change in y is greater than if x changes from 0.3 to 0.4. Now let's say that we want to include more than one regressor in the model. So instead of just having a PI ratio, we also want to include the race of an applicant in the model. Again, the phi is a function of cumulative normal distribution, and whatever is inside this function is called z-value. So estimating a Probit model with multiple regressor is pretty straightforward. Just as before, we use the command Probit and the option "r", and we put the dependent variable first and the regressors or independent variables. As you can see, the coefficient for black variable is actually 0.70, and it's statistically significant because the p-value is less than 0.05. So we can say that the coefficient on black is statistically significant at 5% and even at 1%. So let's say now that we want to estimate the effect of being black, given that the PI ratio is 0.3. In this case, we obtain the coefficients from the data table for the constant as well as the PI ratio and the coefficient for being black. And basically, we need to estimate the predicted probability of being denied when an applicant is black. So in that case, you include the value equal to 1. And if the applicant is white, then you would include the value for black as 0 because the applicant is not black. And then for the PI ratio, we'll put in 0.3 to obtain the predicted probability of an applicant when an applicant is black versus white. So in order to estimate the predicted probability in Stata, we can use this option in Stata command where you put display normal probability function and put in the constant variable or constant coefficient, the coefficient for PI ratio, and the coefficient for being black. We also put in the value that we want to estimate. So in this case, our PI ratio is 0.3. And if you want to estimate the predicted probability of a white applicant, the value for coefficient black would be 0. And this would calculate, or this would output the predicted probability of being denied. So this is an easier way to calculate the predicted probability in Stata. So first, you do need to run the Stata command Probit first, and then you can use this Stata command display norm probability and input the z function inside to make Stata calculate the predicted probability. So this _b constant, this indicates the estimated intercept. So instead of putting the actual value, so you could have just put in this number in the function, but instead you can use this as a substitute. So Stata recognizes that when you put this underscore B, bracket underscore constant. The data recognizes this as we need to grab the intercept from the previous data table, same as the underscore B and bracket P ratio. So when you say this, data recognizes that we need to grab the coefficient of P ratio from the previous generated data table. So make sure that when you use this display option to calculate the predicted probability, you have to run the Probit function first. So the display command knows which coefficient to grab. But if you don't want to use this underscore B option, you can also actually input the actual numbers. So calculating the predicted probability of being denied in data, we found that we can get that the predicted probability for white applicant is 7.5% and for black applicant is 23.3%. So the difference in rejection probability is the difference between the two predicted probability, or it's 0.158%. So compared to on white applicant, black applicant has a higher denial rate of 15.8 percentage points. However, because we're only including the PI ratio and the race variable, there could be a bunch of other factors that are correlated with the race variable and also affects the probability of being denied. So this model likely suffers from omitted variable bias.